Okay, in this video, I'm going to teach you how to undo functions. And this is going to be kind of the heart of Algebra 2, where we start talking about these higher level functions and how can we undo them. So let's start with this word that you probably remember from Algebra 1 that I misspelled because it has an E at the end. Inverse operations. Well, what does the word inverse mean? It means the opposite. And if you can hold this idea in your head, if you can learn this right now, today, it's going to make Algebra 2 and your experience so simple. So what if I was to say I'm going to square something? Well, I would say, okay, here's something, and I'm going to square it. And if I were to ask you what is the opposite of it, all you do is take that same word and add the word root. So the opposite of a square is going to be a square root. Okay. What if I were to say I'm going to cube something? Well, that's going to be x to the power of 3. And so let's see. If a square, the opposite is a square root, then the opposite of a cube should be a cube root. Really good. Okay. But what if I have something to the 4th power? Okay, so let's write x to the 4th. Okay. Now let's see, what is the opposite of the 4th power? Well, we would take the 4th. What do you think it is? The 4th root. Now, I say that these things are opposites, which when you use them in conjunction with each other, it undoes the function. So what does that mean? Well, let's say I had the square root of x. How do I get rid of a square root? What is the opposite of a square root? Well, it's a square. So, if I square this whole thing, the square root, the square, they cancel, and we get whatever is on the inside. Let's talk about, what if instead of starting out with a square root, what if we start out with an x cubed? Well, what's the opposite of a cube? We know it's a cube root. So, if I take the cube root of this whole thing, doesn't matter if it's on the outside of everything, the cube root and the cube cancel, and we're left over with simply what's on the inside, x. And how about the same thing for a 4th root? Let's see. Let me start out with the 4th root of x. What is the opposite of the 4th root? Well, we raise it to the 4th power. Okay? And the 4th root and the 4th power, they cancel, and we get x. So let's take this concept and let's apply it to some examples with numbers. Okay, let's start out with example 1. Let's say, for example 1, I give you the function f of x is equal to x squared, where, let's say I give you what f of x is, I say that f of x is equal to 25. Okay, so I know that f of x is 25, so where I have f of x right here, I can write 25 is equal to x squared. Now our goal is always to get this individual variable by itself, so once again, think back to that last page. What is the opposite of a square? Well, it's a square root. But remember, in algebra, what I do to one side, I have to do to the other. And so here on the right, we know the square root and the square cancel, and we have the x now by itself, but we need to know what is the square root of 25. So here's what I would tell you to do. Open up your browser, and you can go into Desmos Scientific Calculator. See, it's desmos.com, scientific, and you'll notice here we have the square root button. So I just type square root 25, and you look all the way over to the right, and you have 5. And if you hit enter, you can even record that and go on to a new line. So, going back here, we know the square root of 25 is 5, and there's our answer. X equals 5. Okay, let's look at a second example that's going to be kind of the reverse of the first. So here, let's say f of x is equal to the square root of x, where, and in this case I'm still going to give you f of x, if I could ever draw it, and let's say f of x is Let's say 7. Well, I know that f of x is 7, so I plug it in here, and so we get 7 is equal to the square root of x. Well, think back to that very first page. We have the square root of x. So what is going to be the inverse of the square root? Well, it's that very first word. We're going to square both sides. So what I do to the right side, I have to do to the left. Now here, we know a square root and a square, much like in example 1, they cancel. And when I go over here to my Desmos calculator, I can simply type 7. And here where we see a squared, I type that button, it gives me a square. And we see all the way over here, 7 squared would be 49. So, my answer here is that in this case, x is equal to 49. Now let me go ahead, I'm going to start doing a couple more examples. You can kind of speed this up. So let's see, clear this off. Now let's go to our third example. Let's say, and let me even choose a different function here. Let's say g of x is equal to x cubed, so x to the power of 3, where, and here I'll say g of x is equal to, let's say 125. I'm going to pick a big number here. Okay, so g of x. We know g of x is 125. Wherever I see g of x, I'll plug in 125 is equal to x cubed. And right now, ask yourself, how do I get rid of a cube? What would I do? I would take the cube, what word? The cube root. And the cube root, it's like the square root, just with a 3. What we do to the right, of course, we have to do to the left. Now those cancel, and we're left over with an x. But what is the cube root of 125? And this might be a little intimidating. So we go over here, and I want you all to see where it says the square root to the n. See how I click that? And my little, that little line blinking is up in the top left. Well, for a cube root, we just push 3. And then we go down here, inside the cube root, we'll type in 125. And look, it turns out the cube root of 125 is simply 5. It's a nice, easy number. So, the answer to our question is, of course, going to be 5. Let's try our fourth example. And at this point, I think most of you probably have it down, but let's just try again. Let's say, okay, in this case, we have h of x is equal to, and let's do the cube root of x here. Okay, now let's see, what do we want h of x to be? Let's say, you know what, let's do kind of a larger number. Let's say h of x is going to be 11. Well, when h of x is 11, right here, I write in an 11 for h of x, and we have the cube root of x. Okay, so ask yourself this question. What gets rid of a cube root? Well, it's always going to be that first word. We are going to cube that right side. So what we do to the right, we have to do to the left. So we'll cube the 11. And so I go back to my calculator, and here I'll write 11. And then we look over here, see where it says a to the power of b? I push that, and that allows me to type in the number 3. So now we're cubing it, and you'll see that gives us 1,333. So go back over here, turns out 1,330, I'm sorry, I missaid that. 1,331. 1,331 is equal to our original x value. Okay, I'm going to show you all one final example just to make sure that we fully have this. And so here's our last example. Example number 5. You know what? In honor of it being our 5th example, let's say this. Let's say w of x, so just any generic function, is equal to x to the power of 5. Okay? And let's say that f of x is equal to, you know what? Let's choose the number 32. Oh, and you know what? I made a mistake. That shouldn't be f of x. That should be w of x. Okay, so I can say 32 is equal to x to the power of 5. Well, let's see. If we have the fifth power, what is the opposite of the fifth power? We would take the fifth root, and what we do to the right, we have to do to the left. Okay, so the fifth root and the fifth power cancel, and of course we achieve what we want, which is to get x completely by itself. Now here, I go back to my calculator, and we'll hit this radical to the power of n, and the fifth root, we put a 5, and then inside the radical, we'll put 32, which of course gives us 2. So, we can go back here, and x equals 2. Alright, I hope this helps. Good luck, and I'll see you guys in our next lesson.